This video is on Bohr models of atoms, ions, and isotopes. So we've talked already about the atom and how an atom is a neutral particle where my number of protons equals my number of electrons. There are two other things that can happen to an atom. If an atom gains or loses electrons, it can become an ion, and if an atom gains or loses neutrons, it can become an isotope. So an atom is a neutral particle where my protons equal my electrons. An ion has a charge. It can be positive or negative. And we get this by adding or subtracting electrons to make that charge. My protons, remember, have a charge of +1. My electrons have a charge of -1. In an atom, my protons equal electrons, so these charges cancel out. My positives cancel out with my negatives. But if I start to gain electrons, I'm going to have more negative than positive, so that makes my overall atom negative to be a negative ion, which is an anion. If I lose electrons, I have more positive protons than my negative electrons. That makes my overall charge of my atom suddenly become positive, turning it into an ion, also called a cation. So ions have a charge. Isotopes, these have different mass numbers. I can get a different mass number by adding or subtracting neutrons. Remember that my mass of my atoms is in the nucleus, where I have my protons and my neutrons. So I want to look at three different ways we can write chlorine as the atom, the ion, and the isotope. So I've gone ahead and drawn the skeleton of your Bohr model to begin with. Here I have our symbols written. Remember, mass number over atomic number and our symbol. And then if we have a charge, our charge is written in the upper right-hand corner. A charge tells me right away that I have an ion. Otherwise, I need to check to see, is it an atom or is it an isotope? If we look on our periodic table, we can see that there are numbers written underneath our symbols. Remember, these are average atomic masses and not mass numbers. If we're looking between our ion and our atom, we can see that our atomic numbers are the same and our mass numbers are the same. This tells me that this is my atom because my mass number is the same for 2 out of the 3. The only thing that changes when I get an ion is my charge because I've added or subtracted electrons. As an isotope, I can see that my mass number is different between the 3 of them, so that it tells me right away that I have an isotope. Because for each one of these I'm looking at is chlorine, that means my protons for all 3 of them is the same. Protons are equal to the atomic number, so my number of protons for each one of these is 17. I get my number of neutrons by taking my mass number minus my atomic number, so 35 minus 17 is 18. So for my atom, I do that. For my ion, same mass number, atomic number, so it also has 18 neutrons. For an atom, we know that my protons equal my electrons, so if my protons are 17, my electrons must also be 17. So now when I write my Bohr model, in my nucleus, I have 17 protons and 18 neutrons. Looking at my electrons, my innermost shell, I have 2 electrons. My third ring, I have 8 total electrons, giving me a total of 10, but I need 17, so that means 7 more go in my outermost ring. When I make my ion, I have this charge of -1. A negative charge means that I've gained an electron. In this case, I've gained 1. So instead of having 17 electrons, I now have 18 electrons. That means my total, I have 17 plus my -18 gives me an overall charge of -1. That means that I have 1 more electron than I did before. My nucleus of my ion is the same as my atom, of 17 protons and 18 neutrons, but my number of electrons has changed. My innermost ring, I still have 2, and then my second ring, I have 8. But now my third ring, I've gone from 17 to 18 electrons. That means that instead of having 7 along the outside, I've added 1 more electron, right here to be 18 total electrons, or 8 in my outermost shell. You'll find that most atoms who form ions either increase my total number in my outermost shell to be what my maximum is, or I'll get rid of all my electrons in my outermost shell, and that shell will go away. For my isotope, my atomic number was the same, but my mass numbers changed. So now for my isotope, I take 38 minus 17, which gives me 21 neutrons. So in an isotope, my nucleus changes. So now I have 17 protons and 21 neutrons. My electrons are the same as my protons because there is no charge here. So my electrons for my isotope are the same as my electrons for my atom of 17, which means my Bohr model will look the same with my dots of my electrons.